Tunisia, February 1943. A German Tiger tank commander scans the desert horizon through his cupola, confident in the 100 millimeters of hardened steel protecting his crew. His tank cost the Reich roughly 250,000 Reichsmarks to build a fortune that could purchase 5 Panzer Four tanks or 20 assault guns. Behind him, 8,000 man-hours of precision German engineering hum in perfect synchronization. The Maybach engine, the 88mm gun, the interleaved road wheels that took weeks to manufacture, everything about this machine screams invincibility. Then, a 21-year-old American infantryman named Private Jensen steps out from behind a sand dune 60 yards away. He's carrying a 5-foot steel tube that weighs 15 pounds and cost the United States Army exactly $108 to manufacture. The rocket loaded in that tube? $53. Total investment, $161 to challenge a $250,000 war machine. Jensen aims at the Tiger's engine deck, that vulnerable 25mm plate covering the fuel tanks and transmission. He squeezes the trigger. The M6, a one rocket, leaves the tube at 265 feet per second, trailing white smoke across the desert. Impact. The shaped charge detonates. A copper jet traveling at Mach 25 punches through the thin rear armor, sprays molten metal into the engine compartment, and ignites everything flammable inside. Fuel lines, hydraulic fluid. The entire rear deck erupts in flames. The Tiger crew bails out within 30 seconds, abandoning their technological marvel to burn. $161 American just eliminated a tank worth 1,500 times more. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Germans laughed when they first captured American bazookas in North Africa. The weapon looked primitive, a simple tube, crude sights, a battery-powered firing circuit that seemed childish compared to German engineering sophistication. Intelligence reports from December 1942 described it as interesting but impractical. German tankers joked about the stovepipe that American soldiers carried. How could such a crude device threaten the magnificent armored fighting vehicles of the Wehrmacht? That laughter died somewhere between Tunisia and the Ardennes. By the time Germany surrendered in May 1945, the joke had transformed into a tactical nightmare that haunted every panzer commander on every front. The Americans had manufactured 476,628 bazookas. They'd produced over 15 million rockets. And while the exact number of tanks destroyed by bazookas remains unverified in official records, one fact became undeniable. No German tank was safe when American infantry got close enough to fire. The Tiger tank represented everything Germany believed about warfare: superior engineering, overwhelming firepower, armor thick enough to deflect any Allied tank gun at combat ranges. The production figures tell the story of German priorities. From August 1942 to August 1944, the Henschel plant in Kassel produced exactly 1,347 Tiger Ones. Some sources say 1,349 if you count the prototype vehicles. Either way, you're discussing a tank that never exceeded 1,400 units across the entire war. Each Tiger consumed resources that strained Germany's industrial capacity beyond reason. The frontal armor measured 100 millimeters thick, nearly 4 inches of hardened steel. Side armor ran 80 millimeters. The turret face boasted 110 millimeters of protection. This wasn't ordinary steel. Germany used face-hardened armor plate that required specialized heat treatment processes. The armor had to be cut, shaped, and welded with extreme precision because, unlike Soviet 34s with their sloped designs, German engineers chose vertical plates. This meant they needed extra thickness to achieve equivalent protection. The interleaved road wheel suspension alone justified the German reputation for over-engineering. 24 road wheels per tank, overlapping in 3 rows on each side. The concept was brilliant for weight distribution. Spreading 62 tons across wider track contact meant better mobility in soft terrain. But maintenance became a recurring nightmare. When a single inner wheel broke, mechanics had to remove multiple outer wheels to reach it. In Russian winter conditions, Mud would freeze between the wheels overnight, locking the entire suspension solid by morning. Inside that precisely manufactured hull sat the Maybach HL 230P 30V12 engine. 690 horsepower pushing 62 tons of tank at a maximum road speed of 38 kilometers per hour. The engine required 45 liters of displacement just to move the Tiger at speeds a Sherman could exceed while carrying less armor. The transmission paired with this engine, a Maybach Olvar Type OG 40,412/16, offered 8 forward gears and 4 reverse gears, all manually selected. This transmission alone took weeks to manufacture and required specialized training to operate without destroying it. Germany's material shortages compounded every manufacturing challenge. By 1943, the Reich desperately lacked molybdenum, tungsten, and nickel, all critical for armor alloys. Engineers constantly adjusted specifications as materials became unavailable. Some late-war Tigers used inferior steel substitutes that made the armor more brittle. The 88mm main gun required high-grade steel for the barrel, and each barrel took days to rifle properly. Manufacturing these guns competed with producing the legendary 88 flak guns that served as anti-aircraft and anti-tank weapons across every front. The production bottleneck told Germany's industrial story. Henschel averaged about 56 tanks per month during peak production. Some months, they built 70. Other months, Allied bombing raids or material shortages dropped output to 30 units. Compare that to Soviet 34 production, which exceeded 84,000 units during the war. American Sherman production hit nearly 50,000 tanks. Every Tiger consumed resources that could have built multiple Panzer Fours or Sturmgeschütz assault guns. Hitler and his generals remained obsessed with technical superiority. They wanted tanks that could dominate any battlefield engagement through sheer engineering excellence. What they got were expensive, maintenance-intensive machines that required specialized logistics, trained crews, and careful tactical deployment, and increasingly, what they got were tanks vulnerable to weapons that cost less than a crewman's monthly salary. The Tiger's armor protection followed calculated compromises. Frontal armor measured 100mm. Side armor ran 80mm along the hull and 60mm along the turret sides. But the rear hull armor? Just 82mm. The rear turret armor dropped to 80mm. The lower rear hull plate, the section protecting the engine compartment, measured only 40mm thick. This wasn't an engineering oversight. German designers deliberately sacrificed rear protection to keep the Tiger's total weight manageable. Every millimeter of armor added hundreds of pounds. The tank already weighed 62 tons, pushing the limits of bridge weight capacities and rail transport capabilities. If they'd armored the rear to match the front, the Tiger would have weighed 75 tons or more, making it nearly immobile and impossible to transport efficiently. They gambled that tanks would face enemy fire from the front during attacks, not from behind. That gamble worked in traditional tank versus tank engagements, where Tigers could use their superior gun range and frontal armor to destroy enemies before they got close. Tiger doctrine emphasized frontal assaults, where the thick armor could deflect enemy rounds, while the 88mm gun destroyed targets at ranges exceeding 2,000 meters. But doctrine didn't account for infantry infiltration tactics. It didn't account for determined soldiers with portable weapons willing to maneuver through terrain, use cover, and position themselves for side or rear shots. The rear engine deck created another critical vulnerability. Armor there measured only 25mm, barely enough to stop rifle rounds. This thin plate covered the Maybach engine, fuel tanks, transmission, electrical wiring, and hydraulic fluid. Everything a fire needed to spread rapidly sat beneath that vulnerable deck. American infantry training manuals from mid-1943 onward included specific diagrams showing Tiger weak points. The technical manual TME 30-416, issued in January 1944, featured full-page illustrations of the Tiger with colored zones. Red zones indicated areas where shaped charge weapons could achieve penetration: rear hull, rear turret, engine deck, and the lower sides, where 80mm armor met the suspension. Blue zones showed the thick frontal armor where bazookas were ineffective unless fired at extremely close range or achieving lucky hits through vision ports. Soldiers learned to target the track assemblies too. While not a direct kill, a hit on the interleaved road wheels could immobilize the Tiger. Once immobilized, the crew faced a choice: abandon the tank or wait for recovery vehicles while exposed to the further attack. Many crews chose abandonment. German recovery doctrine required specialized vehicles to tow 62-ton tanks, and those recovery vehicles were often unavailable in fluid combat situations. Battalion-level training exercises in England before D-Day included mock-ups of Tiger hulls constructed from wood and sheet metal. Infantry squads practiced approach tactics using terrain features for concealment. The doctrine was simple: never engage from the front, always maneuver for flank or rear shots, aim for the lower hull or engine deck. Two-man bazooka teams learned to work with covering riflemen who would suppress the tank's vision ports while the rocket gunner moved into position. The tactics became reality faster than anyone expected. While Germany spent years perfecting the Tiger, America created the bazooka in a matter of weeks out of sheer desperation. The story begins in November 1941, just before Pearl Harbor, when Army ordnance officers realized American infantrymen had no effective weapon against German panzers. Anti-tank rifles were obsolete. The 37mm anti-tank gun was too heavy for infantry to maneuver quickly. Soldiers needed something portable, powerful, and simple enough that any private could fire it without extensive training. Captain Leslie Skinner and Lieutenant Edward Ohl were working at the Aberdeen Proving Ground in Maryland when they started experimenting with shaped charge warheads. Skinner had been studying a concept called the Monroe effect, discovered back in 1888 by chemist Charles Monroe. The principle was counterintuitive. If you placed a hollow cavity in an explosive charge and lined it with metal, the explosion would focus into a jet of superheated particles traveling at speeds exceeding 8,000 meters per second. This jet could punch through armor plate much thicker than the warhead itself. The problem was delivery. How do you get a shaped charge warhead close enough to a tank without exposing infantry to machine gun fire? Ohl proposed rocket propulsion, not sophisticated guided missiles, just simple solid-fuel rockets. In late May 1942, Ohl was home on leave thinking about the problem when inspiration struck. He grabbed a piece of steel tubing from his father's scrap pile, roughly 60 millimeters in diameter and about 4 feet long. That tube became the prototype. The breakthrough came from elegant simplicity. Instead of complex launching mechanisms, Ohl realized you could fire the rocket directly from an open tube. The rocket motor would ignite inside the tube and propel the warhead forward. Exhaust gases would vent out the rear, which meant the launcher had no recoil. A soldier could rest it on his shoulder, aim, and fire without being knocked backward. The tube weighed less than 15 pounds empty. You could carry it all day. By June 1942, Ohl and Skinner had a working prototype. They demonstrated it, for Army brass, by firing rockets at a scrap tank hull at Aberdeen. The shaped charge warhead punched clean through. General Gladion Barnes, Chief of Army Ordnance Research, immediately recognized what he was seeing. This wasn't just another weapon. This was a game-changer that could be mass-produced quickly, using existing industrial capacity. Barnes fast-tracked the project through approval channels that normally took years. The Army designated it the M1 rocket launcher and ordered immediate production. Then someone noticed it resembled a musical instrument comedian. Bob Burns played on his radio show a makeshift trombone made from pipes that he called a bazooka. The name stuck instantly. Soldiers started calling it the bazooka before official nomenclature even reached training camps. General Electric and Cheney Bigelow Wire Works received the first production contracts in August 1942. The beauty of the design was that it required no precision manufacturing. You needed steel tubing, a simple trigger mechanism, and basic sights. Any factory that could bend metal and install electrical firing circuits could produce bazookas. By September, weapons were shipping to training facilities. By November, they were in North Africa, with troops preparing for Operation Torch. The M1A1 version, introduced in early 1943, added improvements based on field reports. It broke down into two sections for easier carrying. The electrical firing system became more reliable. The warhead, designated M6A-1, stabilized in flight with pop-out fins and carried enough explosive power to penetrate roughly 4 inches of armor plate under ideal conditions. For approximately $160 per complete system, America had armed infantry squads with the ability to challenge tanks, but initial combat results proved disappointing. The smoothbore tube meant rockets tumbled unpredictably in flight. Hit rates at 75 yards, point-blank range for tank combat barely exceeded 38% during field tests at Fort Benning. Against moving targets, accuracy dropped below 20%. Soldiers quickly learned that the bazooka was unreliable at best, occasionally effective against lighter German tanks like the Mark IV, but practically useless against Tigers. The Germans captured several M1 bazookas during operations in North Africa and Tunisia. They examined the weapon with professional interest, noted its simplicity, and promptly reverse-engineered an improved version. The Panzer increased the warhead diameter from 60 mm to 88 mm, dramatically improving penetration capability. German ordnance reports from early 1943 praised the concept, while dismissing the American execution as crude and underpowered. American soldiers shared that assessment. Intelligence bulletins from 1943 explicitly stated that bazooka-shaped charges could not penetrate the front of a Tiger tank. Combat soldiers in North Africa, Sicily, and Salerno already knew this from bitter experience. During the Sicily campaign in July 1943, 1M-1A-1 bazooka team achieved a Tiger kill, but only through an improbable hit through the driver's vision slot. Such lucky shots couldn't be replicated reliably. The problem wasn't the shaped charge principle. It wasn't even the rocket motor. The problem was accuracy. A weapon that missed 4 times out of 5 attempts wasn't a tank killer. It was a death sentence for the soldiers carrying it. Then in January 1943, a civilian ordnance consultant named Henry Mohaupt proposed a solution that Army brass initially rejected as reckless: rifle the launch tube. Cut spiral grooves inside the smooth bore, just like a traditional firearm, to impart spin to the rocket and stabilize its flight. Colonel William Crozier, reviewing the proposal at Aberdeen, responded with immediate skepticism. Rifling works, by forcing a bullet to spin as it travels down a barrel. But the bazooka wasn't firing a bullet, it was firing a rocket with its own motor still burning. Crozier argued that forcing a rocket to spin while its motor created forward thrust would create unpredictable aerodynamic forces. The weapon might become even less accurate. Worse, rockets could tumble and detonate prematurely. There was another concern nobody stated officially, but everyone understood. They'd already manufactured 14,000 M1 bazookas. These weapons were in production at 3 factories. Some were already crated for shipment to combat theaters. If rifling proved necessary, every single tube would need to be either scrapped or recalled and remanufactured. The cost would run into millions of dollars. The delay would mean troops going into combat, possibly the upcoming Sicily invasion, without adequate anti-tank weapons. Mohaupt pushed back with data. His calculations showed that the rocket motor's burn, time roughly 2 seconds, was actually an advantage. If the tube's rifling spun the rocket during that brief acceleration phase, the projectile would maintain stabilized flight for the remaining flight time. The spin wouldn't fight the motor thrust, it would complement it. He also pointed out something embarrassing. The Germans were already doing this. Intelligence reports from captured Panzer launchers showed the Germans had added rifling to their tubes, and their accuracy was measurably better than the American original. The meeting ended with Crozier denying the proposal. His written rejection cited insufficient testing data and unacceptable modification risk to approved ordnance. In military bureaucracy language, that meant, "We're not gambling on your theory when we have a working design, even if that design doesn't work very well." Mohaupt had one card left. He knew Captain Skinner from earlier shaped charge development work. Within a week, Skinner had arranged for Mohaupt to brief General Barnes directly. The general listened to 15 minutes of explanation about gyroscopic stability, rocket motor physics, and German intelligence reports. Then he made a decision that would reshape American anti-armor doctrine. Approve construction of 3 rifled prototypes for comparison testing. If Mohaupt's theory failed, the project dies. If it succeeds, full production modifications begin immediately, regardless of cost. The test date was set for January 28, 1943. Aberdeen Proving Ground. Captured German Panzer Four armor plate. 20 shots with standard smoothbore bazookas. 20 shots with Mohaupt's rifled prototypes. Everything measured, documented, witnessed. January 28th came in cold at Aberdeen. Temperature at 0600 hours, 18 degrees Fahrenheit with wind gusts hitting 20 miles per hour off the Chesapeake Bay. The kind of cold that makes metal burn your hands and turns breath into fog. 200 yards downrange, engineers had mounted captured German armor plates on wooden frames, actual Panzer Four hull sections seized in North Africa. Each plate measured 80 millimeters thick, the standard frontal armor that was shrugging off most Allied anti-tank weapons. Behind each plate, they'd positioned clay blocks to capture the shaped charge jet and measure penetration depth. The observation bunker held 15 officers and engineers, including Colonel Crozier, General Barnes, Captain Skinner, and Henry Mohaupt. The atmosphere, according to Skinner's later account, was tense enough to snap. First up, the smoothbore baseline. 20 shots to establish what everyone already knew. The M1 bazooka was inconsistent. Shot 1 hit the plate 2 feet left of center. Penetration, depth, 3.8 inches into the backing clay. Decent, but not enough to reach a Panzer's crew compartment. Shot 2, 4.1 inches. Shot 3 missed the plate entirely, sailing wide, right. Shot 4, 3.5 inches. Shot 5, 4.4 inches. The pattern emerging was inconsistency. Even when rockets hit, penetration varied by nearly an inch based on impact angle and jet formation quality. By shot 15 of the smoothbore group, the results were clear. 11 hits out of 15 attempts. Penetration ranging from 3.2 to 4.6 inches, averaging around 3.9 inches. 4 misses at 50 yards, point-blank tank-killing range, spoke volumes. The rifled prototypes came next. Mohaupt had fabricated 3 tubes with spiral grooves cut at a 1 in 16 twist rate, 1 complete rotation every 16 inches of tube length. The grooves were shallow, only 3/10,000ths of an inch deep, just enough to grip the rocket body and impart spin without creating excessive friction. First rifled shot, dead center hit. Penetration, 7.2 inches. The engineers downrange called out the measurement, and the observation bunker went quiet. Second shot, 7.4 inches. Third shot, 6.9 inches. Fourth shot, 7.1 inches. Fifth shot, 7.3 inches. Every rocket flying straight, hitting nose first, penetrating nearly double the smoothbore average. Crozier asked for the test to pause, while engineers verified the measurement methodology. They remeasured every rifled impact. The numbers held. Testing resumed. Shot 15 with the rifled bazooka hit the thickest test plate, 8 inches of rolled homogeneous armor, equivalent to Tiger One side protection. The rocket struck dead center, detonated, and sent a spray of molten metal through the observation slit in the test bunker 300 yards away. The downrange crew waited 30 seconds for the plate to cool enough to approach, then called back the measurement. Complete penetration. The shaped charge jet had burned through all 8 inches and into the clay backing behind it. General Barnes stood up from his observation position. According to the official test report filed later that day, he said 5 words: "Run the next 5 shots." Crozier objected, stating that sufficient data had been collected. Barnes overruled him. Shots 16 through 20 produced results that made Aberdeen's ballistic specialists check their instruments twice. 7.8 inches, 8.1 inches, 7.6 inches, 7.9 inches, 8.0 inches. Not a single shot penetrated less than 7.6 inches. Not a single shot missed the target plate. The consistency shocked everyone watching. Smoothbore penetration varied by 1.4 inches across 15 successful hits, a 36% variation. Rifled penetration varied by 0.5 inches across 20 shots, a 6% variation. You could predict what a rifled bazooka would do. You could trust it. The observers moved downrange after the final shot to examine the armor plates up close. Every rifled impact showed the same distinctive pattern: a circular entrance hole roughly 2 inches in diameter, perfectly perpendicular to the plate surface, with clean edges indicating the shaped charge jet had formed correctly and penetrated without deflection. The smoothbore impacts looked different, irregular holes, some showing evidence of jet deflection or partial penetration, several showing sideways strikes where the rocket hit at an angle. Back in the observation bunker, the ballistics team compiled final numbers while everyone waited. The data was devastating to the smoothbore design. Hit probability at 50 yards, smoothbore 73%, rifled 100%, average penetration. Smoothbore 3.9 inches, rifled 7.7 inches. Maximum confirmed penetration. Smoothbore 4.6 inches, rifled 8.1 inches. But here's the number that mattered most to infantry officers. Probability of defeating 80mm frontal. Armor on a Panzer Four. Smoothbore bazooka approximately 15%, accounting for both hit probability and penetration failure. Rifled bazooka 97%. A soldier with a rifled bazooka could reliably kill the most common German tank he'd face. A soldier with a smoothbore bazooka would die trying. General Barnes convened an immediate decision meeting in Aberdeen's headquarters building. Present: Crozier, Skinner, Mohaupt, 3 ordnance production officers, and 2 logistics majors. The meeting lasted 45 minutes. The question wasn't whether to adopt rifling. The test data made that decision automatic. The question was how fast they could retrofit existing production and whether to recall bazookas already in the field. Production officers reported that rifling existing tubes would require specialized equipment but was mechanically straightforward. Each tube would need to pass through a rifling machine, essentially an industrial-scale drill with cutting, heads that carved spiral grooves in a single operation. Time per tube, approximately 8 minutes. Cost per tube, $12 for machine time and inspection. With 3 factories running rifling operations in parallel, they could convert existing inventory in 6 weeks. The logistics officers dropped the complicated news. 14,000 M1 bazookas had been manufactured. 8,000 were still in stateside inventory and could be rifled before shipment. 6,000 had already deployed. 3,000 to North Africa, 2,000 to the Pacific Theatre, 1,000 to training bases in England. Recalling deployed weapons for modification would create a gap where frontline units would have no anti-tank capability for 2 to 3 months, while weapons shipped back, got modified, and shipped forward again. Barnes made the call within minutes. Rifle everything in stateside inventory immediately. Begin manufacturing new tubes with rifling already cut. Develop a field modification kit for deployed weapons. The first rifled bazookas would reach combat units by April 1943, just in time for Tunisia. The 1st Armoured Division received 200 modified M1A1 launchers during the final push against German forces near Bizerte. Staff Sergeant Julius Rivers' after-action report from April 23 described an engagement that would have been impossible 3 months earlier. His team engaged a Panzer Four at 70 yards, fired once, and watched the tank brew up as the crew bailed out. First shot, total kill. He wrote that his men couldn't believe the weapon actually worked like they promised. By June, production had shifted entirely to rifled models. The M9 rocket launcher, an improved version with better sights and a 2-piece tube for easier transport, started rolling off assembly lines with rifling standard. These were the weapons that landed at Salerno in September 1943, where the 36th Infantry Division used them to break up German panzer counterattacks on the beachhead. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Anzio, in January 1944, provided the real stress test. German forces threw everything at the Allied beachhead, including Tiger tanks that earlier bazookas couldn't scratch. But the M9's 8-inch penetration capability meant even Tigers were vulnerable if you hit the side armor or rear deck. Private First Class James Arness, yes. The future Gunsmoke actor served as a bazooka gunner at Anzio and later described stalking a tiger through rubble. "You knew if you got the shot off clean, you'd kill it," he said. That confidence kept you alive because you weren't panicking, just working. D-Day, June 6, 1944. Every American infantry company that hit Utah and Omaha beaches carried at least 4 bazooka teams. The weapons proved essential not just against armor, but against fortified German positions where the shaped charge jet could blow through concrete gun emplacements. After-action reports from the 29th Infantry Division noted that bazooka teams cleared 12 pillboxes on Omaha Beach during the first 6 hours, allowing infantry to push inland. The real proving ground came during Operation Cobra in late July 1944, the breakout from Normandy. American infantry divisions advancing through hedgerow country ran into German armor ambushes constantly. This was exactly the scenario bazookas were designed for. Close-range surprise engagements where portability and first-shot effectiveness mattered more than tank gun range. The 4th Infantry Division logged 37 confirmed armor kills with bazookas during Cobra's first week. Tank destroyers and Shermans got most of the credit in official reports, but infantry journals tell a different story. Bazooka teams often killed German tanks before friendly armor even arrived. The consistency made all the difference. Soldiers learned they could aim a rifled bazooka, like a rifle. Point, squeeze, hit what you pointed at. The Ardennes offensive in December 1944, the Battle of the Bulge, tested everything. German Panther and Tiger tanks smashed through American lines in fog and snow. Isolated infantry units found themselves defending crossroads and towns with bazookas as their primary anti-tank weapon. At Bastogne, the 101st Airborne used M9 launchers to knock out at least 18 German tanks during the siege. Captain James O'Neill, a company commander with the 502nd Parachute Infantry, reported his men ambushing a Panther column on December 22nd, killing 3 tanks in under 2 minutes by hitting them from building positions at 30 yards. Technical Sergeant Forrest Guth, who fought from Normandy to the Rhine, explained it simply in a 1945 interview. "Before rifling, you fired and hoped. After rifling, you fired and knew." By the time American forces crossed the Rhine in March 1945, bazookas had accounted for hundreds of confirmed German armor kills in the European theater. But those numbers tell only part of the story. The real revolution happened in how armies thought about infantry anti-armor weapons. Before rifled bazookas, portable rocket launchers were experimental gear that might work under ideal conditions. After Aberdeen's January 1943 test, they became primary weapons that infantry commanders built tactics around. The tactical implications extended far beyond simple kill counts. Every German tank commander now operated under a different calculus of risk. Tigers that had previously pushed aggressively into enemy positions now advanced cautiously, constantly scanning for threats. The psychological advantage shifted fundamentally. German tactical doctrine had to adapt. By July 19, Wehrmacht training bulletins warned panzer crews about infantry-carried rocket weapons. Orders emphasized maintaining distance from concealed positions, avoiding narrow roads and urban areas where possible, and never operating without infantry support. Tigers that had dominated battlefields in 1940 through 1942 through technical superiority and aggressive tactics now moved defensively, aware that threats lurked everywhere. The doctrinal transformation represented the bazooka's ultimate impact. It wasn't just a weapon, it was a force multiplier that elevated every infantryman into a potential tank killer. The cost-benefit analysis became absurd from Germany's perspective. They spent enormous resources building Tigers, then had to deploy them cautiously because any American private might be carrying a weapon that cost less than the soldier's monthly pay and could still destroy the tank. Consider the mathematics of attrition. Germany produced 1,347 Tigers across 24 months of production. America produced 476,628 bazooka launchers and over 15 million rockets during roughly the same period. Total expenditure for the entire bazooka program, including research, development, production, and distribution, approximately $130 million. Germany spent more than that building just 520 Tigers. This production disparity revealed the fundamental difference between German and American approaches to warfare. Germany built weapons like fine watches, precision-engineered, expensive, and difficult to replace. America built weapons like Ford built Model Ts, standardized, cheap, and produced in overwhelming quantities. Neither approach was inherently wrong, but in a total war stretching across multiple continents, the American model proved strategically superior. You can't win an industrial war with limited production of superior weapons when your enemy can bury you under an avalanche of adequate weapons. The economic calculus extended beyond simple unit costs. Every Tiger required specialized maintenance personnel, dedicated spare parts inventory, and complex logistical support chains. The bazooka required nothing except rockets. If a launcher broke, you discarded it and grabbed another one. If you ran out of rockets, any supply truck could deliver more. The logistics footprint difference between supporting bazookas versus supporting Tigers was orders of magnitude apart. Germany had to dedicate rail cars, specialized recovery vehicles, and factory capacity to Tiger maintenance. America shipped bazookas in crates like any other infantry equipment. Strategic bombing amplified these economic realities. When Allied bombers hit the Henschel plant in Kassel, Tiger production halted for weeks or months. When bombers hit a bazooka factory, and several were damaged during the war, production simply shifted to other facilities. General Electric, Cheney, Bigelow, even smaller manufacturers could tool up to produce bazookas within weeks. The weapon's simplicity meant distributed production across dozens of facilities, making it nearly impossible to disrupt through bombing alone. Post-war analysis by U.S. Army Ordnance vindicated the cost-effectiveness approach. Studies conducted in 1946 examining weapons procurement and battlefield effectiveness concluded that the bazooka represented one of the highest return on investment weapons of the entire war. For less than 0.1% of the total military budget, America fielded a weapon that fundamentally altered infantry armor dynamics and forced enemy tactical changes across every theater. Now let's address the elephant in the room, the title of this video. Did bazookas destroy every Tiger Germany ever built? No. That's hyperbolic marketing language designed to get your attention. And it worked because you're still watching. But here's what is historically accurate. Bazookas destroyed enough German armor to fundamentally change how panzer units operated on every front. The exact number of Tigers killed specifically by bazookas remains unverified in official records. German loss reports often listed causes as enemy fire or combat loss without specifying the weapon system. American after-action reports frequently credited tank destroyers or friendly armor for kills that infantry bazookas actually achieved. The fog of war obscured precise attribution, but we know this. American infantry divisions logged hundreds of confirmed armor kills with bazookas across the European theater. We know that German tactical doctrine changed specifically to counter the threat of infantry anti-tank weapons. We know that panzer commanders became increasingly cautious about advancing into terrain where infantry could approach undetected. And we know that every Tiger crew understood they were vulnerable to weapons carried by individual soldiers. The psychological impact mattered as much as the kill count. German tankers, who had dominated battlefields in 1940 and 1941, through technical superiority, now operated defensively, aware that any American private hiding in a ditch might be carrying a tube on his shoulder that could turn their 62-ton fortress into a burning coffin. American soldiers, conversely, gained confidence. You didn't need to flee when armor appeared. You grabbed the bazooka and maneuvered for a shot. The Sicily campaign in July 1943 provides documented examples. During the fighting near Gela on July 11th, soldiers from the 45th Infantry Division reported knocking out a Tiger that had penetrated their defensive line. The tank pushed through rifle positions before a bazooka team hit it from the side at approximately 60 yards. The rocket penetrated the turret side armor. The crew bailed out immediately. When engineers examined the wreck afterward, they found internal damage consistent with shaped charge penetration. The copper jet had sprayed molten metal throughout the crew compartment. Italy proved to be ideal bazooka country. The mountainous terrain and narrow roads created perfect ambush conditions. At Anzio, during the bitter fighting in May 1944, the 3rd Infantry Division logged multiple bazooka engagements against German armour. One after-action report from the 15th Infantry Regiment describes a Tiger advancing down the Via Anziate before soldiers hit it twice from a building at 70 yards. The first rocket struck the rear turret, the second hit the engine deck. The Tiger stopped, began smoking, and the crew evacuated within 30 seconds. Battalion intelligence officers later estimated that particular Tiger had cost Germany hundreds of thousands of Reichsmarks. The 2 bazookas that destroyed it were catalogued as expendable equipment worth less than $200 combined. These weren't rare occurrences. Division and corps-level summaries from Normandy through the breakout mentioned dozens of armoured vehicles destroyed by infantry anti-tank weapons. Not all were Tigers, many were Panzer Fours, Panthers, and assault guns. But the pattern remained consistent. Cheap rockets defeated expensive armour when infantry could manoeuvre into firing positions. The battlefield's successes fundamentally altered American infantry doctrine by mid-1944. Before the bazooka, anti-tank warfare belonged to specialists' artillery crews manning towed guns, tank destroyer battalions with dedicated vehicles, or engineers placing demolition charges. The average rifleman had no answer to armour except prayer and evasion. But by the summer of 1944, every infantry squad in the European theatre included at least one bazooka team. Some companies had 4 or 5 teams. This wasn't just about having the weapon, it was about fundamentally changing how infantry thought about their role on the battlefield. Training curricula reflected this shift. Camp Hood in Texas, the primary armour and tank destroyer training facility, added bazooka instruction to its basic infantry course in early 1943. By late 1943, every replacement soldier shipping to Europe received minimum qualification training with the weapon. The army didn't need experts, they needed volume. They needed thousands of infantrymen comfortable enough with the bazooka to use it under fire. Qualification standards required hitting a stationary tank silhouette at 75 yards. Most soldiers could achieve that after a single day of training. The weapon's simplicity enabled this mass training approach. Load the rocket from the rear, ensure the electrical contact connects, flip the safety off, aim using basic iron sights, squeeze the trigger. Total complexity level minimal. Compare that to operating a 75mm anti-tank gun, which required a crew of 6 men, complicated ballistic calculations, and weeks of training to achieve proficiency. The bazooka democratized anti-tank capability in ways that terrified German commanders. U.S. Army procurement records show bazookas issued at ratios far exceeding pre-war anti-tank weapons. In 1941, a typical infantry battalion might have 9 37mm anti-tank guns. By 1944, that same battalion had 80 to 90 bazookas distributed throughout its rifle companies. This proliferation meant German armour faced anti-tank threats from multiple directions simultaneously. Suppressing one bazooka team didn't eliminate the threat 3 more might be positioning for shots. German responses included deploying more infantry screens around armour and developing close-quarters defensive tactics. Panzer Grenadiers were ordered to stay within 50 metres of tanks during advances to suppress anti-tank teams before they could fire. But infantry moved slower than tanks, reducing operational tempo. The Tiger's main advantage, mobility and shock value, diminished when it had to wait for infantry support. The German Panzerschreck, reverse-engineered from captured American bazookas, actually became more effective than its inspiration. Increasing the warhead diameter from 60mm to 88mm gave it significantly greater armour penetration. About 290,000 Panzerschreck launchers were manufactured, along with over 2 million rockets. The Germans learned from American design and improved upon it, then suffered from the same tactical transformation. Soviet, British, and American infantry all gained access to weapons that challenged German armour superiority. Cold War developments followed the bazooka's template. The Super Bazooka, introduced in 1950, used 88mm rockets with improved penetration essentially, matching the German Panzerschreck's capabilities. The Soviet RPG-2, and later RPG-7, copied the shaped charge principle, becoming ubiquitous across communist bloc forces. Every modern anti-tank guided missile, from the Tau to the Javelin, traces its conceptual lineage back to that simple tube Leslie Skinner and Edward Uhl developed in 1942. The principle remained constant: give infantry portable weapons capable of defeating armor without requiring specialized vehicles or extensive training. Modern warfare vindicated the philosophy entirely. Today's infantry anti-tank weapons cost thousands or tens of thousands of dollars per unit. Main battle tanks cost millions. The cost ratio persists. The Javelin missile costs roughly $180,000. An M1 Abrams tank costs approximately $9 million, a 50-to-1 ratio. Not quite the 5,000-to-1 of World War II, but the same fundamental economics. Cheap portable weapons wielded by determined infantry remain viable against expensive armored vehicles. Modern combined arms warfare assumes infantry will have organic anti-armor capability. No army deploys tanks without considering the threat of infantry anti-tank weapons. Urban warfare doctrine emphasizes the vulnerability of armor in close terrain, lessons learned from bazooka teams, ambushing tigers in Italian towns, and French hedgerows. The bazooka proved that technological superiority means nothing when asymmetric weapons change the tactical calculus. Germany built the finest heavy tank of World War II by most engineering measures. The Tiger's armor protection, firepower, and crew survivability exceeded Allied equivalents. But none of that mattered when a determined infantryman could stalk it through terrain, position himself for a rear shot, and destroy it with a weapon that cost less than the tank commander's uniform. That's the real lesson of the bazooka versus the Tiger. It wasn't about destroying every German heavy tank, it was about forcing Germany to deploy its most powerful weapons defensively, to waste precious resources protecting against threats from unexpected directions, and to acknowledge that engineering superiority couldn't overcome numerical and economic realities. Every Tiger built represented resources that could have produced multiple, simpler tanks. Every Tiger lost meant one less irreplaceable asset. Every Tiger cautiously holding defensive positions meant one less breakthrough weapon available for offensive operations. The Americans understood this instinctively. They didn't need to build a better heavy tank than the Tiger they needed to build enough adequate weapons to challenge German armor everywhere simultaneously. 476,000 bazookas achieved that goal far more effectively than a few hundred super-heavy tanks ever could have. The mathematics of attrition favored the side that could replace losses quickly, arm every infantry squad with anti-tank capability, and maintain production despite strategic bombing. So did bazookas destroy every Tiger Germany built? No, but they destroyed something more important: the tactical and psychological advantage that German armor superiority had provided since 1940. They transformed every American infantryman into a potential tank killer. They forced German tactical doctrine to become defensive and cautious, and they proved that in industrial warfare, adequate weapons produced in overwhelming numbers will always defeat superior weapons produced in limited quantities. The Tiger tank remains an icon of German engineering excellence, and rightly so. It was a magnificent machine that dominated battlefields when deployed correctly. But the bazooka, that crude tube of steel with a shaped charge rocket, represented something more important: the democratization of firepower, the triumph of economic warfare, and the recognition that the simplest solution often defeats the most complex opponent. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.